Hey, what's up, guys? Yeah, so in this video, let's talk about let's quickly remind that the two theorem fundamental in a very fundamental number theory. And the first one is the Fermat's little theorem. Okay, so our goal is let's consider P is R prime. So the Fermat little theorem tells you that a to the P minus 1 is 1 mod P. Let's say A is coprime to P. And the second theorem that also commonly used is this Wilson's theorem. P minus 1 factorial is minus 1 mod P. Okay, so for example, you can check that 2 factorial, right, is just 2, where it's minus 1 mod 3. And 4 factorial is 24 is minus 1 mod 5. Okay, then you can easily check it. Okay, this video that I will quickly go through to prove. Go through these two proof, and hope you guys subscribe to my channel. And so proof idea basically is very simple, just using the FP is a field. Okay, so that will be enough for you to prove this theorem. Okay, so let's go to the Fermat's little theorem proof. So I will provide two proof. Okay, so proof one. Proof one is very simple, right? So you can consider A, 2A, 3A, and the P minus 1A as a set. Okay, so I claim that this set is just permutation of 1, 2, 3 up to P minus 1 if I just mod every guy by P. Okay, the reason is that you can check, right? If MA equals to NA mod P, the same, it means that M minus NA is the multiple of P, but A is coprime to P. That means that P equals to N mod P, which is impossible, right? Because I consider M and N both from 0 to 1 from P minus 1. Okay, so then I can do a product, right? So I can product A, 2A, 3A up to like P minus 1A. That will A equals to 1, 2, 3 up to P minus 1 mod P. So all these numbers can cancel. So I get A P minus 1 equals to 1 mod P. Okay, very simple proof. Okay, so second proof. Okay, so second proof using the binomial coefficient. The idea is the following. So one can check that A plus P, B to the P will be A to the P plus B to the P mod P. Okay, the reason is that all the binomial coefficient with the prime as the number as on the top. Basically, what I'm saying is that P to the N is P divides P to the N if N is this, right? If N is from here, then there's always the P factorial will not disappear, right? Because there's not enough number to cancel the largest P. Okay, and so one can check more that if you have AI to the P, that will be the AI to the P mod P. Okay, so using this, that one can just, let's say I add 1 from 1, 1 add 1 on 1 add, let's say A of them, and I go power P, this will be A to the P, okay? But in the mod P field, I can write 1 to the P, 1 to the P, 1 to the P. So I get 1 to the P, 1 to the P, 1 to the P, 1 to the P, and I layer A of them and the mod P using this. Okay, so I get A to the P equals to A mod P. Okay, and now notice that A is coprime to P, so this implies that AP minus 1 is 1 mod P. Okay, so second proof should be very simple. Let's go to the Wilson proof, the Wilson theorem. I think these two theorems are commonly used in the elementary number theory, so I like to make this video. Hope you guys subscribe. And so what we are going to do is that P minus 1 factorial is minus 1 mod P. Okay, so the idea is that or notice FP is a field, right? So each element A can find its inverse. Okay, and okay, so for example, let's do a very simple example. Let's say P is 7. So I consider 1, 2, 3, 4, 5, 6, and the inverse is the inverse. Okay, so inverse of 1 is 1, inverse of 2 is what? Is 4, right? Because 2 times 4 is 8, 8 minus 7 is 1, 3 is 5, 3, 2, 6. Okay, so we can see that the only unpaired one will be the 1 and the p minus 1. Okay. So simply speaking, so x squared equals to 1 minus p has only two solutions. Why? Why? Because p is a field. Because p is a field. So this is very important. Okay, the very important thing is that if you have a field, then the n degree polynomial at most have n roots. Okay, so they only have two solutions. Then I can find these two, right? Because I know that x can be plus or minus 1 minus p. So I know that only 1 and the p minus 1 are unpaired or paired with itself. Okay, so that means that if I do 1 times 2 times 3 up to p minus 1, then I will get a lot of pair. So all these will pair. When I get 1 and p minus 1, let's say I'm at p, right? Because all these are pairs, so they are paired with the multiple of 1. So I finally get p minus 1 factorial is p minus 1 mod p, where is minus 1 mod p. Okay, so these two theorems are like commonly used in the number theory. So I hope you guys enjoy this video. See you guys next video.